على بركة الله نبدأ بإذن الله عز وجل. I just want to start with a quick comment. I'm honored to be among this. Can you hear me? Okay. I am really honored to be among this distinguished group of professionals who are not only passionate about process safety, but also among the best in the field. Thank you so much for all for being here. Today I'll be sharing some of my thoughts about the importance of having an integrated approach and an integrated framework for process safety. But before I go too far, I'm a proud worker for BASF, and I just want to make a disclaimer that anything I say today or present represents my personal views and professional views, not those of BASF. BASF has nothing to do with what I will be saying today. So with that, I will just start with maybe moving around a little bit. Start with giving an overview of the framework of my presentation. We'll talk about process safety and whether it should be the priority number one or not. And we'll talk about some of the unintended consequences of process safety. Then we'll talk about the integrated approach towards process safety and how we should approach it. And I say process safety should not be priority number one. It should not be the first priority. I even say process safety should not be a priority at all. Process safety should be a core value. And this is not about semantics or playing with words, but anytime you put a priority on process safety, that priority will go up and down depending on who's in charge and how committed they are toward process safety, how much budget they have, how much business pressure, and so on. We've seen that in different incidents in the industry. So process safety must be a core value that go with us on driving our cars, going to our homes, and definitely at work. Often people look at process safety as a cost, as a liability. Every time in the plant you talk about process safety things, oh, one more time we have to pay money. Actually, this is the wrong way to look at process safety. Process safety is a value-adding investment. The well-known saying, if you think process safety is expensive, try an accident, is very true, right? We've seen it all over the place. Also, we shouldn't be approaching process safety in isolation of the big picture. Process safety is part of the big portfolio, the risk portfolio for the organization and the company, and it should be integrated in that manner. We shouldn't be talking about process safety as a check-the-box exercise. And one last thing, I think, some education from our side. We all know what's the difference between occupational safety and process safety, but a lot of people outside do not. So I think we need to help people understand that process safety is about the process itself, the design, the explosions, the fires, etc. Whereas occupational safety, which is equivalently important, is about hard hats and boots and long-term exposure and so on. All right. Now, we say process safety should not be a priority. But once you started your process safety process and you come up with action items, those action items to close the gap are subject to prioritization. You have limited amount of money and people and resources, and you have to use a risk-based approach to determine where do you start and which one you start on first. Is my voice clear, or am I? Okay, good. Typically, you would look at different items when you look at the risk-based approach. You would look at the level of risk of the issue you have. You would look at the age of the facility, because if you have an older facility, you would want to take care of it first, probably. You look at the number of people affected, whether internally or externally. And you want to look at the environmental impact also. So these are some, not an inclusive list, but some of the factors you look at it. And once you determine you have a high risk item, like on this here, if you use the risk matrix, we all use risk matrix in the process safety community. Once you determine you have a high priority item, then you give it priority 1 or priority 2. And typically in the industry, we have a time limit on priority 1 items. And it's different company to company, but sometimes we give it 1 year max. But in the interim, you have to have interim measures. You can't have a high severity, or not a high severity, a high risk item, and leave it for a year until you put the permanent risk. You have to put something in the interim, temporary, to fix it until you have the final fix. And priority 2, you could go 2 or 3 years. Of course, some regulatory requirement like OSHA does not allow you to go beyond 2 years, I believe, on your action items without justification. Risk-based approach, we start with typically identifying the hazard. Identifying the hazard related to our chemicals and their physical and chemical properties. We look at the equipment, at the process conditions. Basically, you look in the water and you see some sharks, and that's your hazard, right? Your next step is to determine the level of risk. You may want to go next to the sharks and see how bad they are, right? And then, once you determine your level of risk, you want to determine the best way to either eliminate the risk. You could shoot your sharks and get rid of them, or you could replace them with dolphins. You could go and look your chemistry. If you have really nasty chemicals or highly hazardous chemicals, think about, can I replace this chemical and still get the same products, right? Inherently safer design, as we will talk about it later on. You want to talk about reduce the risk. You could cut the jaws of the shark that bites you and be safe that way. Or you could put barriers between you and the hazard. Basically, you have administrative controls, PPEs, and so on. But there is no risk-free process, as we all know. There is a tolerable level of risk we have to live with. If when you drive your car in the morning, there is a risk in driving the car. But we all know the risk, and we accept it. And that's what we strive to in the chemical industry and in process safety, is to know the risk and accept it at a certain level, because we cannot be risk-free. That has to be clear. Now, 2 things I guess we need to pay attention to in the process safety community. It's very important to avoid risk transfer or avoid the Cobra effect. The Cobra effect, you probably know, goes back to the time of the British rule of India, when they have in Delhi a lot of snakes, cobra snakes, and it became really a nuisance. So they said, how can we solve this problem? And a genius idea came in to pay money for anybody who bring a dead snake. So people started to look for snakes, kill them, and get money for that. And the problem started to improve. The snake population started to go down. But then the entrepreneurial mentality came in and said, okay, why don't we breed cobras and sell them to the government? So people start to breed cobra and sell them to the government and get money. By the time the British knew that scheme is on, they stopped it. They stopped giving money for the cobras, for the snakes. And now you have breeders with these snakes, a lot of snakes, but it's worthless. So what did they do? They released it. So you started with a problem, but you ended with a bigger problem. Cobra effect. Always, any decision you take in process safety, think about the Cobra effect. We have many of these stories in the chemical industry. An example I choose here, basically cooling tower treatment. People used to use chlorine gas for the treatment of cooling towers. And people thought chlorine is toxic, and if we have a release from these gas cylinders, we could kill people. So let's find an alternative, an inherently safer alternative. And what was the alternative? It was bleach. Bleach is liquid, and it's less hazardous. You could control it better. So people started to use bleach instead of chlorine in the industry to be inherently safer. But what happened after that? There's an increased demand on bleach, and people start to build plants to produce bleach. And to produce bleach, what do you need? Chlorine. So people started to pile up huge amounts of chlorine, and we transferred the risk from a moderate risk in the plant to a bigger risk everywhere else. And also, in addition to these huge reserves of chlorine that could be released any time. If you have an inadvertent mixing with sulfuric acid, you could release chlorine too. So it's very important when we make decisions in process safety to think about unintended consequences. Just wanted to start with this and share it with you. Now, for the integrated approach to process safety, before I start, I just want to mention the two incidents, sad incidents in Jordan that claimed the lives of 20 plus people, the chlorine incident and the grain silo incident before that. As a process safety professional and as a Jordanian also, I was really passionate to go and find some information about what happened, and an investigation report, see what happened. But within the public domain, I could not find anything tangible. I reached out to some friends that I know in the academia and industry, and I couldn't get anywhere. So I think what I found that we have as a country, we lack an investigative body, an independent investigative body that when we have an incident, they are ready to go. I mean, this is not a political speech in any way, but just to talk about the facts from a technical standpoint. As far as I know, the investigation committee was led by the Interior Minister, all the respect for him, and the committee was a little bit heavy in the law enforcement agencies. And this is good when you start the investigation. You want to rule out any criminal or terrorist threats, right? Once you determine this is not criminal, this is not terroristic, then you want to hand it to the professional. So we need to have an independent investigative body that is really there. We'll talk about some examples in the future. How do we improve the situation? In my views, what we lack strongly in Jordan and in the region is a national legislative framework for process safety and for the environment as well. You cannot do anything about process safety without bringing everybody up to the same level. The national legislative framework will put everybody at the same level with the minimum requirements. We don't want to over-legislate. We don't want to kill the industry. We want the industry to be at a level where, okay, here you start and go and improve on it. So we have to have a national legislative framework, and in my views, the outcome of this national legislative framework should have a regulatory entity, an enforcement entity that goes and inspect and issue fines. You need technical non-regulatory entity, investigation, and you need some research and improvement, and we'll see some examples later on. Obviously, the way the laws are made in Jordan, you all know, the government has to propose something to the parliament, and the parliament has to approve it. So I hope that will happen. But we know without some constructive collaboration and pressure, things may not be done. My hope is for the Jordanian Process Safety Society, along with the Jordanian Engineering Association, along with the Jordanian worker unions, also in collaboration with the SMEs from academia and industry, to have some collaborative effort to lobby for a national legislative framework for process safety. This is non-political. It doesn't matter what's your ideology. This is about people's safety. So I highly hope and encourage us here and those great entities to do some lobbying, do some constructive pressure on the government and the parliament. Shukran. Once we have a national legislative framework, then we can talk about an integrated approach to process safety. And the way I see it, that's only my views, typically we have 3 pillars for process safety. We start with inherently safer technologies and design. You want to start with that, eliminate as much of the hazard upfront as you can. Of course, with it comes some engineering controls and facility siting and such. But your second pillar is your management system and programs. You could have the best design in the world, but we people operate these machines and equipment, so we need some management systems to help us manage the risk. And ultimately, a big problem globally, I can assure you this is not only here, globally, process safety culture. Some companies are better than others, some countries are better, but the mindset, people mindset and the people component. If you have these 3 components, and you always should strive for continuous improvement. One important factor, I gave it a different color, process safety education in universities. I think it's very critical for our universities in the region, not only in Jordan, to incorporate process safety education in the curriculum. And as a standalone course, but even more importantly, in addition to a standalone course, try to incorporate process safety education in the different courses. If you're teaching kinetics and reaction engineering, talk about runaway reactions, talk about how contaminants sometimes can act as a catalyst and you lose control over your reaction. If you're teaching people about distillation, after you teach them the fundamentals, talk to them about if you lose your overhead condenser, or if you block the valves around it, what would happen to the temperature and pressure profile inside? If you're teaching them about pumps, talk to them about blocking in. We're human beings, sometimes by mistake we block in the discharge and suction, and if the pump is operating, the temperature will rise at a rate of 4 degrees per minute, and the pressure will raise about 9 bar per minute, and in no time they will explode. So process safety doesn't have to be a standalone course. It's great when it is, but also try to incorporate it in the curriculum. Back to the legislation. I think we have to have, as a result of having a national law to organize process safety, we have to have an enforcement entity that will ensure compliance, do the inspection, issue citation, issue some investigation. The investigation done by the enforcement agency typically to determine liability and who's right and who's wrong and who get penalized basically. If you want to think about the US model, talk about OSHA and EPA. The OSHA 14 elements is a good start. It's not enough for process safety, I can assure you that. But it's a great start. If you start with the 14 elements and build on it, you'll be in good shape. The EPA also with the hazardous chemical and so on. So that's the regulatory and enforcement. The second part is to have non-regulatory body, which is the investigative body. Typically, this is investigation, thorough investigation to determine the root causes and issue recommendation how to avoid the accident in the future. It's something similar to what the CSP, the Chemical Safety Board in the US does. It goes there and so here's the deal. You have an accident. You don't go and form a committee to investigate the accident. You have the board already there with qualified investigators, and you just deploy them. And that's what we're lacking in the region. We don't have that. And yes, we can talk about all these great initiatives, and I was pleased to hear Dr. Al-Amair and Mohandas Bani Taha talking about all these initiatives. If you have a national legislative framework, guess what? These will be a natural byproduct and it will be very easy. So I think it's very important that we put some effort on it. Research and improvement. There are governmental entities and non-governmental entities, as you can see, but there's a big role for non-governmental entities, whether it's in the academia or standalone research centers. We have, as an example, the CCPS from the AICHE. You have the Mary Kay O'Connor Process Safety Center. We have the IChemie, Trish is here, and so on. These institutions typically are of great help for the industry. Let's talk about the technical side, inherently safer design first. Let's see if you can give me a reminder on the time when it comes. Inherently safer design is basically, you probably all saw this before, is when you put an effort on the design phase to eliminate any hazards up front. You look at your chemistry, you look at your operating conditions, you look at many other things we will talk about. Try to eliminate it up front instead of dealing with it later on and install expensive instrumentations. Then you have around your process, you have all these layers of protection. Of course, inherently safer design is mostly beneficial at the design and development phase, but it's valid throughout the life cycle of the process. You don't stop there. In our PHAs, when we do the risk assessment, we always look for inherently safer design solutions first before you go for more expensive solutions. So as you know, substitute, minimize, moderate, and simplify. For the substitution, you want to ask yourself, is there a chemical in my process that I can replace with a less hazardous chemical? can I change the whole chemistry around my process so that I don't have to deal with either severe operating conditions or toxicity or flammability? An example is acrylic acid synthesis from propylene oxide. When it came out, it replaced the older technologies that produced carbon monoxide and hydrogen chloride and acetylene and many of these really hazardous chemicals. We can look at our solvents. We know solvents are flammable. Now, when you deal with them, you have to take some precautions. Can we deal with water-based, solvent-free technologies? Always ask these questions and make sure if you have a flammable, can I replace it with non-combustible, less volatile, less toxic, and so on. So it's very important to ask these questions specifically at the development phase and the construction phase, but throughout the life cycle of the process. Minimize. Anytime you mention minimize, you remember the Bhopal incident in the early 80s where at least 5,000 people get killed from methyl isocyanate. They have, as you all know, 42 tons of methyl isocyanate, a highly toxic material, stored in the plant when they did not need to have that much. Methyl isocyanate was not a final product, it was an intermediate. So the inherently safer design approach is to design your MIC plant next to your final product plant and produce it and consume it. You don't have to store it that way. Always some of the questions we need to ask. Do we need all these inventories? We have all these storage tanks. Take a second look at your storage tank and inventories. Do you really need them? Or can you reduce the amounts? Or do you, when you design your process, can you minimize the piping? Can you get the units close enough to each other so that you don't have to have long pipes that are exposed for release and so on? Just think about how to minimize your holdings and of hazardous material. Look at your process. If you can use wiped film evaporator instead of traditional distillation columns, can you use basically centrifugal extractor instead of traditional extraction column? Can you use continuous reactors instead of batch reactors? All these things are a safer alternative that you should look at when you deal with your process. If you look at this here, traditionally we have the reactor, we have the distillation column, but if you combine them together in a reactive distillation process, you could minimize a lot of the inventory and the hazard. Moderate, you want to look at your operating conditions. Do I really need to run at 300 PSI and 400 C, or can I use a better catalyst that will moderate my operating conditions? Can I improve my chemistry? Can I, you want to make sure that you don't just get stuck with what you have. Always ask the question and try to moderate the condition. I think the ammonia technology is a good example where we started with really high temperatures and pressures, and over the years we brought the operating conditions almost to half of that. And that's not only good for safety, it's good for operation. It's less cost, operational cost. Talking about moderate, do you really need to use anhydrous ammonia, or can you use hydrous ammonia, liquid form of ammonia? It's better and more aqueous HCl instead of anhydrous HCl, sulfuric acid, nitric acid, all these things. Do you really need to use all these concentrated forms, or can you use alternative concentrations or forms of your chemicals? Simplify. It's very important to make sure that your design is simple enough to minimize human error, because we operate the plant and we're prone to human error. Make sure, for example, if you have multi-purpose unit, you can, one reactor that you use for different processes, can you separate them? Do you really have, anytime you have multi-purpose unit, you are more prone to commit mistakes. So try to simplify the design and make it friendly to the operators and engineers so that they can operate it without being subject to error and accidents. If you look at this scheme here, you have your reactor. Apparently, if you have a highly hazardous chemical, you need a PSV, pressure relief system, and you cannot release it to the atmosphere because it's hazardous. So you need a catch tank, you need a scrubber, you need a stack, you need to burn it. if you design your equipment to withstand the maximum worst pressure scenario up front, then you'll probably delete all of this. You just make sure that the worst pressure that you can experience, that your MAWP, maximum allowable working pressure for your vessel, can handle that. Limit the effects. This is when we talk about when we build our facilities. We need to first stay away from communities or sensitive recipients like schools and mosques and churches and community centers and all these things. But we know in reality, sometimes you build it and they come and build next to you, right? So you can't solve the problem all the time, but you need to establish safe distances. Even within the plant, we have rules in the industry, in the company I work for. There's a minimum distance, let's say for 100 meters between any flammables and a permanent source of ignition, or even a temporary source of ignition. So keep that safe distance. Understand your impact radius. We cannot operate without flammables and explosive and reactives. We know that. But understand what's the impact radius in case you have a release or an explosion. And within that radius of impact, try to make sure you have a blast wave resistant building, you have shelter in place, you have all what you need so that you can mitigate the risk. Process safety management systems. This is a big topic. I don't want to get deep into it. I just want briefly to touch on it. Typically, as I mentioned several times so far, you start with your national legal requirement that puts you at a certain level, and you use your RAGAGIP, basically recognized and generally accepted engineering practices. You need your process safety programs and management systems like your MOC, management of change, incident investigation, PHAs, process safety information. You need to put them in place, and you need them to talk to each other. You want to make them integrated. You don't want somebody who look at the PHA is clueless about the MOCs that triggered that PHA, and so on. So make sure you have clearly defined responsibilities and accountability, and there's a big emphasis on the reporting culture. When you have something get released, we need to report it because we need to learn from it, and we need to make sure also sometimes it gets out into the sewer system or out to the environment and so on. Process safety culture. That's a big topic, and it's a bit tough to handle it, but typically process safety culture is about our shared commitment toward process safety for doing the right things all the time. And it starts with feeling that everybody is responsible for process safety. It's not the process safety officer. Everybody, from operators to engineers to management, etc. The concept of ownership. If I am in the plant and I see a problem, I own it until the real owner show up or until I delegate it to somebody else. I don't just walk away from it and say, it's not my problem. Process safety, this is a very important concept, at least for me. Process safety is not in conflict with the plant's priority. Process safety is important for the plant priorities. Make that relationship with the plant, with the operators, and have that partnership mentality and help them out address the issues. We'll talk about in a little bit more detail later on. Emphasize the value that process safety brings. As I mentioned earlier, people talk about process safety, it's a cost. We have to install a safety instrumented system or PSVs or whatever and pay money. But think about protection of people, protection of assets, and reputation. Guess what? These big incidents, they have names attached to it. Anytime you mention the BP Texas City, the BP company's name's there. The Exxon Valdez, Union Carbide in India. So try not to make your company's name appear with one of those mega events because your reputation is important. Reputation is important not only for the company well-being, also for the stakeholders when you have private companies that are traded in the stock market. Your customers typically, when in big companies like ours, when we have contractors, we look at their process safety history, and we don't hire them unless they meet certain criteria. Operational discipline. It's a big, big thing in process safety, and a lot of incidents are attributed to operational discipline. And operational discipline, as defined by Dow, is the commitment to do the right thing every time, right? Now, operational discipline should be practiced not only by operators and engineers, it should be practiced by higher management. Start with higher management and trickles down, because if you don't do that, then it's meaningless. Let's talk a little bit about the role of executive and high-level leaders. The high-level, the CEOs and the C-suite, basically. They need to provide enough budget. And if you look at the BP incident report, you know what I'm talking about. You look at higher management pressure to reduce cost, and what was the victim? Process safety. There were a lot of maintenance, a lot of process safety related issues that were either delayed or brushed off, and that was by pressure from executive leadership. Then visibility, especially during times of uncertainty, especially the COVID time. You don't want your leaders to be in their offices. Open communication is critical. Everybody in the company should feel safe to talk about their concerns, their valid concerns when it comes to process safety. Credibility and trust is the foundation of leadership. Any leader who does not demonstrate that is not going to be successful. When it comes to plant management, they still have to meet these criteria, but also they have different kinds of pressures. If I am the plant manager, do I really need to stop, shut down, and lose money on production and have to justify to my higher leadership what I'm doing? The answer is yes. If you need to do it, do it. And it's not easy sometimes to make that decision if you're a plant leader or if you're a production leader, but if you need it, actually you should do it. Address root causes, about fatigue management in your plant, look at your high turnover rate. Typically it's either related to fatigue or pay or something else. And make sure you learn from previous year's operation, what mistakes has happened, what good practices has happened, not only about the mistakes. For us in the engineering and operation world also, we need to make sure we adhere to the procedures every time we do our things. We don't take shortcuts, we don't normalize the deviation, right? And it would be great if we normalize excellence. That was a great comment. And something very important, operators and engineers, but particularly operators, need to have the stop work authority. And in a company like ours, we grant that. If you're an operator, you see something wrong, you have the authority to stop the work for safety reasons, and you will not be retaliated against. So that's very important to have. Active participation in all these MOCs and incident investigation, self-development, and so on. And there are a couple of topics that are not talked about a lot, and I know some of the presenters will be presenting presentations related to that. Psychological safety and human factors. Psychological safety has to do with the openness of the higher up leadership. You see this line going to open communication. Can I, if I am the operator, can I really express my concern without being retaliated against? That has the level of stress and human factors, I think, will be covered in many other presentations. Finally, for process safety, it's very important for us to maintain independence. You shouldn't be reporting to the business directly. If you report to the business directly, you will be subject to their pressure. And I've experienced it firsthand, and sometimes it's very tough to say no to higher ups. You also want to emphasize the partnership. Partnership, not policing. We are not policemen of the plant. We go there to help people with good attitude. We make that partnership. We talk to them. It's the worst thing in the world when you go there with the attitude that this is wrong. That's not how you should do it. Also, don't only point out the problems. Our job is to participate in the solution. We sit down for weeks doing PHAs, and we point out all kinds of problems, but sometimes we forget, as process safety professionals, to propose solutions. We are engineers in the first place. So don't just point out the problem, try to participate in the solution and understand operational constraints. You have to be sensitive to the plant because it's not just simple to shut everything off, but try to resist the pressure when needed. Very briefly, typically you all seen the Swiss cheese model. where you have a hazard, an incident, and you have layers of protections. Typically, each layer has holes in it. We start with process technology, equipment design, engineering controls, all these things. Our goal is to find these holes and plug them, or at least make them not aligned temporarily. Sometimes there are holes in your process technology. Your equipment design will deflect that. Sometimes things will go all the way to your dike and loss of primary containment. Unfortunately, sometimes we end up with an accident. So let's look at the layers of protection around us and make sure we plug them, because ultimately, what we need to stay in the green area to avoid any loss of containment. And ultimately, what we need to do is to start with design integrity. You want a good design. We all agree on that. But that on its own is not enough. We need to construct it. Construction integrity. When we build it, we need to make sure that we build it right. But once we build it right, we don't stop there, right? We need to ensure asset integrity. You have to maintain your plant in a good shape to make sure it doesn't age with time and start to release chemicals. And you need your operational integrity. But at the heart of all of this is people, us. We are dealing with all these phases, and we need to make sure that we keep developing our education, our knowledge, basically, in this area. To summarize just the topics I talked about, I'm a big fan of dealing with process safety as a core value, not as a priority. And I try to think about unintended consequences every time I make a decision. And it's not easy sometimes. You can't always get it right. But when you have a team, you probably have a better chance. We talked about the integrated approach from inherently safer design all the way. And I'm putting this in blue here, the role of universities in teaching process safety. And by the way, I want to take a moment to extend my gratitude to my former professors here in the audience, who were my professors when I was a student at the University of Jordan a long time ago. Basically, the message I want to leave you with is our safer tomorrow starts today. So we need to collaborate and work together. I think Sabrina Carpenter, an American singer, she has a song starts with, "I'm ready for tomorrow. Tomorrow starts today." So let's start today on process safety. Thank you so much.